Hello, everyone. Today we are going to talk about linear systems of equations in several variables. First, what is a linear equation? Well, there is a first example. This is a linear equation in one variable. The variable is x. X is a variable, and m and b are real numbers, constants. Okay, so second equation has already two variables. And here variables are x and y, so variables. And what are constants? M, k, and b. Everything else are constants. And the third equation has three variables. And they are x, y, and z. So that's kind of how equations in several variables are going to look. Maybe I should erase this. Okay. Why do we call them linear? Why are they linear? You see that the power of x in the first equation, the power of x and y in the second equation, and x, y, and z both have powers are 1. So the first power. Equations with the first power of variable are called linear. For example, if you have a square root of x in your equation, it's still equation, but it's not linear anymore. Can be equation in one variable, but not linear. In several variables, but non-linear. Let's see how do we usually solve equations in like 1, 2, 3, 4 variables. Well, first, I'm going to start with one variable equation. For example, 2x plus 4 equals 0. Example, like a first equation, right? How do we solve it? Well, we separate x and number 4, right? We move number 4 to the right side. And then isolate x, find it by dividing by 2 both sides, right? And the answer is -2. That's our solution, right? Very good. If we have two variables, for example, 2x plus 2y equals 1. We cannot do this because like this way we can find only one variable and we can solve it, but in solution we are going to have a second variable. If we continue working the same way we were working here, we're going to have what? 2x equals 1 minus 2y, and x equals 1 minus 2y over 2. It still has y, so that's not a solution. Why does it happen? Because when equation has two variables and just one equation, there is kind of some degree of freedom of variables x and y here. For example, if I set x equals 1 over here, then I can find out that y, which satisfies 1, is going to be what? Well, let's do it. Let x be equals to 1. Then the equation is going to be looking like 2 by 1 plus 2y equals 1. And that's 2y equals 1 minus 2. I'm moving this 2, and y equals -1 over 2, right? We divide it. So we can find y if we do know x. So values are not totally arbitrary. So for x equals 1, y equals -1 over 2. But there can be more than one solution. If you set up x equals 2, you are going to find a different y for it, and so on. That means that we'll need one more equation to define it if we want to have one solution. Let's see how it's going to look. Second, guys. So when we have two equations, we call it a system. I'm going to combine two equations with two variables. 2x plus 2y equals 1, and x plus 3y equals 3. That's called a system of two equations with two variables. How do we solve the system? Well, for the system solution, we kind of remember we can use either elimination method or substitution. I'm going to show elimination, but actually, you know that substitution is still going to work. Elimination. how elimination works. Well, you, for example, consider equation number 2 and multiply it by something to add to the first equation and cancel either x or y. I'm going to multiply this equation by -2. Multiply by -2. So I have 2x plus 2y equals 1 and minus 2x minus 6y equals -6. I multiplied all the terms of this equation by -2. And then I'm going to add first equation and second equation. This way, what is going to happen? 2x minus 2x is going to cancel each other, right? 2y minus 6y is minus 4y. And here -6 plus 1 is going to give me -5. And my answer here is going to be -5 over -4 or 5 over 4. And what I'm going to do next? Well, I found y. I'll need to find x. I can use for x either first equation or second equation and just plug in y. Well, I actually don't know. I think I'm going to plug it into the first equation. So if it's number 1, then I'm going to plug in y into 1. So it's 2 by x plus 2. Instead of y, I'm going to put 5 over 4 equals 1. Now I'm going to just do calculations. 2x equals 1. Here, 2 and 4 cancels, and we have just 2. So it's 5 over 2. Well, we know that 1 minus 5 over 2, what is 5 over 2 actually? 2.5, right? It's going to be minus 1.5. And let me scroll a little bit. And 1.5, sorry, I have something from the previous lecture on this notebook. So we have 2x equals -1.5 or x equals -1.5 divided over 2, which is minus 0.75. So my solution is going to look like minus 0.75, and y is equal 5 over 4. I think it's 125. Something strange happens to my opinion. 125. That's my solution. And you see there are not many x's and y's which are going to give me the same solution. Well, if I want to use substitution, how would I solve it if I want to do substitution instead of elimination? Substitution. Substitution means that I'm going to consider equation, for example, equation number 2, and solve it for x. I'm going to write down that x equals 3 minus 3y. So I move 3y to the right side. And I'm going to take this x and plug it into the first equation. And 3 minus 3y plus 2y equals 1. Well, we kind of understand that solution is supposed to look same, but let's check if it's going to work. 3 by 2 is 6 minus 6y plus 2y equals 1. And we are going to have minus 4y equals what? 6 over here is minus 5. And y again equals 5 over 4. And then you just plug in this y over here and get x equals 3 minus 3 by 5 over 4, which is 3 by 4 minus 3 by 5 over 4. I'm bringing this 3 to common denominator, multiplying by 4 divided over 4. And I'm going to have 12 minus 15, which is 3 over 4. Minus 3 over 4. And if I write it down, I'm going to have minus 3 over 4 and 5 over 4, which is exactly same as minus 0.75 if I divide over 4 and 125. And that's the same answer I had already. I don't know, maybe it's a little bit faster to do it substitution, maybe a little bit faster to do elimination. I don't really know. Usually I pick up the method randomly. What is going to happen if we have more variables, like 3 variables? Well, let's see how 2 variables is going to be different. 2x plus 2y plus z equals 1. X plus 3y plus 3z equals 3. And y plus z equals 5. So you see it's a system of 3 equations, and it's going to have 3 variables. My variables are x, y, and z variables. Sorry. Well, how do we solve it? You can use either elimination or substitution as you like. I'm going to try elimination, but again, for right now, guys, until we teach you more sophisticated methods of solving systems, both methods are going to work well. What is elimination? Well, I'm going to eliminate this x by multiplying the first equation by -1 over 2. This way I'm going to get minus x here. And, well, let me write it down. So it's, it's minus x minus y minus 1 over 2z and minus 1/2. And I'm going to add it to the second equation, which is x plus 3y plus 3z equals 3. So when I add them together, I'm going to get 0 here, 2y, right? 3y minus y, and 3z plus minus 1/2 is going to give me, well, 3 is 6 over 2, right? So it's 5z over 2. And this one is, again, 5 over 2. Well, now what I'm going to have, I'm going to rewrite my system. 2x plus 2y plus z equals 1, the first equation. And then my second equation already does not have x. It has 2y plus 5z over 2 equals 5 over 2. By the way, we can multiply the whole equation by 2 and get rid of denominator. I think I'm going to do this. So let me do it. I'm going to write down over here 4. Here, no denominator, and here is just going to be 5. What I did, I took my resulting 1 and multiplied it by 2. Well, we can always do this with equation, right? I want to have no fractions in my solution. Now, I have y plus z equals 5. Well, what we can do, guys, we can continue doing elimination. I'm going to eliminate y here. So I'm going to multiply my second equation by negative 1 over 4. So it's going to give me minus y here. Let me write it down, otherwise it's not going to be very clear. Minus y minus 5z over 4 plus 5 over 4, not plus, sorry, equal minus 5 over 4. And here y, z, and just 5. If I add them up, I'm going to get 0 here. Z minus 5z over 4, it's 4z minus 5, it's negative z over 4. And over here, I'm going to have 5 minus 5 over 4. I'll try to bring it to common denominator. It's 20 minus 5 over 4, which is going to give me what? 15 over 4. So minus z over 4 equals 15 over 4. Well, I can multiply everything by 4 and get that z equals minus 15. Well, is it correct? Looks like it is correct, but maybe I did a mistake somewhere. I'm trying to figure out if I'm missing something, because I did a solution of this equation already, and my answer is minus 14. Somehow I got minus 15 here. Just give me a second. Okay, I cannot find if I did something wrong over here, so I'm just going to continue solving the equation. So I found my z. Now I can kind of bring it back into the equation which is underlined and find y, right? So y minus 15 equals 5, from where y equals 20, right? I mean, bringing minus 15 over here. And now I can go back to my first equation and substitute it and calculate x. Now, let me scroll it down. So my first equation is 2x plus 2y plus z equals 1. So I'm going to write down 2x plus 2. My y equals, let me look, 20 plus my z, sorry, is minus 15. Well, I'm going to put minus 15 in parentheses. And now I'm just going to combine all the numbers. So I have 1 minus 15 goes as 5 plus 15 on this side, and 2 by 20 is kind of 40, so minus 40. So I have 2x equals 25 minus 40 is minus 15, or x equals minus 15 over 2. Well, then my solution is minus 15 over 2, y is 20, and z is minus 15, sorry. Started writing down 15 too high. Well, that's solution. Well, solution is supposed to what? If you plug it into your equation, supposed to turn it into a true statement. Well, I'm checking equation number 3. For equation number 3, everything works. We can check equation number 1 or 2. But, well, basically that's all. If you wish to solve equation by substitution, what we can do, you can take, for example, solve it for y and plug in y over here as in terms of z and y over here in terms of z. So solve it for y, express y as z, and substitute into the first and second equation. And that's going to be now about only x and z. And you can kind of solve it, for example, for x from second equation through z and plug x into the first equation. It's going to give you pretty much same time to solve. So that's up to you how you like to solve it. Okay. Okay, guys, I'm hoping that you can practice a little bit with systems of 3 equations, maybe do a couple of systems from your homework. And we are going to have more practice with system of 3 equations when we start partial fraction decomposition. Okay, for now, that's all. And I'll see you next lecture.